This is a similar problem, except we've got this situation here and this one here. Under which condition are they equal to each other, p of x and q of x? Well, when a is equal to, here we just go across to here, to 4, that's straightforward, just like the last question. But when minus 7b is equal to 7, so minus 7b is what's in front here, not just an ordinary number, and 7. So when that is the case, then we have to solve this. So what must b be equal to? And as we can see, dividing minus 7 into 7, it must be minus 1. So it's when b is minus 1. And that works, doesn't it? Because here we've got minus 7. If b is minus 1, what happens? Minus 7 times minus 1. That's what that becomes. That's equal to plus 7, which is what we have here. So b has to equal minus 7. Similarly here, c minus 1 must equal minus 5, just like here. So we do that, get our answer there. That's how they are done. This next one is just continuing the same sort of theme, but getting more complicated. Here we've got 5 is equal to m minus n, and 3 is equal to m plus n. So here we've got these two equations, and we have to use these as simultaneous equations to work out what m and n are equal to. So note how we do this. If we take this first one here, m minus n equals 5, we can juggle it around, so putting the n over here, adding n to both sides, so you end up with m equals 5 plus n. How does that help? Well, if we take this equation now, the other equation, write that down, we've just calculated that, or said that m is equal to 5 plus n. So if I take the m value that's in this equation here and replace it with what it's equal to, which is 5 minus n, that's what happens. We end up with 5 plus n instead of the m, plus n equals 3. Now we can solve it because we only have n's. So we end up with 5 plus n equals 3, so 5 plus 2n equals 3. Juggle it round, minus 5 over the other side, gives us 2n is equal to minus 2, so n is equal to minus 1. And once we know that, then we can just say, well, if n's minus 1, I can use either one of the first equations there, this one will do. So m plus n equals 3, I've just worked out that n is minus 1, so I can replace it with minus 1, and it lets me work out what m is equal to. Notice at the end I always put my answers and highlight them. That's something you really need to do, particularly in exams. Get in the habit of doing it now. Same story for this one here, but even harder. The x cubes are the same, 2x is the same, but this bit here, you've got a squared minus a plus 8 in front of the x squared, and 2a squared minus a minus 1 in front of the other. So this here has to equal this for them to be identical. So we end up with this situation, equating that and equating that, equating them to each other, making them equal to each other. And now we have to go ahead and work it out. So what I've done here is I've taken this whole thing here and subtracted it from both sides. So I've got this, take away that, equals now 0 because that's been moved to the other side. And then when I work through this, I've got the minus outside the front of the brackets, which changes the a squared to a minus, that to a plus, that to a minus, and now I can just gather them together. 2a squared minus a squared is a squared, minus a plus a, that's gone, 0, and this minus this, so I end up with this, a squared is equal to that. And remember, when I take the square root of something, of course it could be plus or minus that value, so here are the two possibilities. A could be either of those numbers. Moving on a little further, again this is just the same thing, it's just getting a little bit more complex. It's the algebra work here that becomes complex, but I'm just equating that's in front of the x. What's in front of the x here? 6, so 6 is equal to 3c minus 3. I'll put that here, and the others, minus 2 is equal to 2 minus a. You just set up those equations and then work out each equation will give you the values of a, b, c and d. I thought it was a bit nasty, this question here. Is it a polynomial? I wanted to say no, because it's only got a number, hasn't it? But of course here 9 is equal to 9 by 1. Now 1 in terms of powers of x is just x to the power of 0. Anything to the power of 0 equals 1. So we can put the x in there. It is a polynomial. It's a polynomial of order 0. Here we're looking at substitution. This is really easy. Substitution of what? Well, this here, for example, tells, so we've got a function p of x is equal to x cubed minus 6x plus 2. What, though, would that be equal to when x is equal to 2? Now the way we write that is p of 2, because we replace the x with a value, 2. So it's just simply a matter of saying, okay, well, all the x's everywhere are now 2's. So it becomes p of 2, x cubed becomes 2 cubed, minus 6 times x becomes minus 6 times 2, plus 2, and we work that out and get our final answer. Don't forget, please, that 2 cubed is not equal to 6, is it? So many people say that. It's 2 times 2 times 2, which is equal to 8. Alright, here's an application of polynomial. It talks about a ball being dropped and so on, but here really we've got the motion described by h of t, h being the height in metres and t being the time. So a ball is dropped, it falls for a certain time. Where is it at any particular point in time? So here's the equation which defines that. So here it asks you to ask how far above the ground is the ball after it's been falling for 3 seconds. So here's the equation. We now know that t is equal to 3 seconds, so we can replace t with 3, replace t with 3 here. We work out the equation. It tells us that the ball is now 55 metres off the ground. It asks what h 1.5 represents. Didn't ask you to calculate anything, just what does it represent? Well, since this is t, h 1.5 represents how high the ball is from the ground 1.5 seconds after it's been dropped. Similar thing, just substituting values of x in here into the polynomial and calculating them. Yep, I think that's all pretty straightforward, just substituting values in here. This problem here is, again, it's just simply a substitution problem, so we're replacing the values of x with whatever the function is, the value is here. So I don't really need to talk about this because they're all the same, aren't they? This one here, now you need to watch out and not get our sort of self in a knot over this. We suddenly start talking about diagonals and polygons, and really all that matters is you've got something which is being calculated. What is it? It is the number of diagonals, but that's what that means. The number of diagonals in something compared to the number of sides. You don't actually even really need to understand that what it's saying is, look, if you've got a 4-sided figure, how many diagonals does that have? And it's 2. What if you've got a 5-sided figure? How many diagonals? Well, you've got one over to that side, one up there. So there's just 2 again. What about other situations in there? So, you know, when you've got figures with many sides, how many diagonals does that actually have? And that's calculated through this equation here. So having got that polynomial, we put 4 in there. That's calculating how many equations each one has. Yeah. Mr. Timewell just asked me a very rude question here about, am I mood lighting for the centre of Mathemagic computer? He's a very rude man, Mr. Timewell, and now this is on the recording too. So they're the look. This is up on the wiki, all of this explanation, so I don't think I need to really go through this anymore. Same with these, all pretty straightforward, I think. Even right down to here. So yep, I'm getting down here to some problems that I haven't yet finished, so I'll finish those off and put them up on the wiki. But they're all just applications for it. I think I've probably said enough about how this works.